to another video where I'm working on Odin's text adventure for, not a text adventure, interpreter for a virtual machine for text adventure games. So it is for the Z machine and it is written in Odin. And what we've got so far, if I work out what the right keys are, basically what we can do is do something like that. I'll just push enter a few times. So what I've got is basically it can parse the header, it can interpret instructions, it can decode instructions, and it can interpret a reasonable few instructions so far. And yeah, it's kind of got ability to reason with objects, so it knows about properties and attributes and children and parents and whatnot. Not completely, but just implement it as it comes up. So what is happening now is we have another non-implemented instruction. So what I usually do here is if we go down here and just run that same make command here, it'll take me to where it is, but it will show me what address is there. And if we run that's txt, what I might do is something like that, and yeah, I could put something fancy there, I guess, but yeah, so what I normally do is search for this HCF F9, and it is print object. And so if we look at dictionary of opcodes, we can see here one op at A, so that's the one there, and A is not implemented, so this is indeed a print object, so we're going to implement that. So what I'll do is just go to the code and do full screen, and I think I want to change this maybe. Well, actually, maybe I just want to put like /op there to make it a bit clearer, and also like lowercase this, so the type, so type is it's like a type, which is way up here. I think I can't easily lowercase that because the V is formatting the like a thing in Odin, and it just represents the value, and the value of a enumeration is just the text of whatever value it is. So yeah, and I also think I'm rat holing here, so I will skip that. So we've got $A, and if we go print obj, and we want to add this in, find underscore to do and obj, so this is what we're doing. And now if we run that same make, it'll fail a bunch of times, but here we can kind of start reasoning with things. So this is in implement. So we probably don't want to search that it's well, what we could do is just, well, actually no, we can just kind of implement it here. So it's got one operand, so we can probably just steal this thing, and just as a safety check, we can chuck in that which we can remove later, because I want to search for object now and kind of see how that's done. So if we get the object, I think we can just go dump object and pass in the object and probably the machine so it can look up where things are. So I kind of want that, so maybe I can do that and then undo and then put it down here in the right place. So I think that is what it is. And here we need to know whether it needs a branch. So I guess here we probably just want to search for pool and then just go print obj comma dot, and here invalid opco, so it doesn't need a store, and I think this did not need a store. If we just search for print obj, it did not need a store, so if we just go back to there, could probably do the same there and go back to pull. It does not need a Z string. Cool, so if we go to this next one, how we, this is like printing, so I think there's like one special case for print. Now there's one for this, so I think we need to get the object. In fact, is there not that, is there some stuff for object? There is. Go back. So I think we can just do something like that. So this is an instruction dump. So I think at this point we can probably do make. We don't know how to dump object. So that is because it is in like instruction dump, we do well, we don't actually do dump object. Yeah, we do object dump, which just does this. So I think this is what we actually want to do. And do this. Right, and now this should work. And right, so it's printing object there, and you see here it's done west of house. It hasn't done a new line, so I wonder if we are meant to do a new line. We are not, so the next instruction, unfortunately that doesn't go to opcodes, but we can go to buff opcodes and BD, this other one. So, and you can't see what it is. So, come on, over there and down there. So, here we want to go to HCFB, which is get parent, and it's 103. So I think I actually want to go to find the fingers. And what was it? It was not that way. It was get parent 1-3. So that's 1 OP. And I don't really want to search. Get out of this mode. That's probably good enough for me. 1-3 is indeed get parent. So yeah, that's pretty much that. Can go and do that. Just need to confirm that you're getting the right thing. So do we actually have any gets? We don't actually have any gets at the moment. So I guess this will be the first. HIJK. So it must be here. Get parent. And what is it? 1 OP. 3, and it is get parent. Cool. So now if we make this, it will fail in a bunch of places. So it's just down here that we wanted to do the get parent. Case get parent. And this will just do unimplemented for now. This is execution. Here we didn't have another one, but it was like ink check, I think. Do we need a branch for get parent? No, we just need a store. It has no branch if exists clause. That's kind of a weird little extra thing to chuck in there. It just has a store. So here we want to find, I don't know, just here and get parent. What's the next one? This is needing a store. It does need a store. So this will be get parent. And does it need a Z string? It does not. Nah, that's not useful. But that is right. So how do we want to print this? I assume just print the object, then the store. So this would probably just be similar to this. Get parent. weird indent there. And just to check that, I want to search for get parent dot star quote. Right, so it does indeed print the parent if it exists. I think I also want to do that. Is that how we do the like one line ifs? No, we needed like a do. Yeah, so I think we only want to do that if we can, and get parent won't need it. But it always has one argument, well, at least one argument. Yeah, is that what I wanted? Yeah, for dumping that seems fine, and the individual execution will do like other assertions. So I think this will get us to a point that we need to work out what we want to get for the parent, and it's just like a normal kind of store and thing, except we only have one. And we have a store. That's going to be the first one as well, and then we want to like write something to the store. Well, how does other store things do it? We just have an instruction dot store. And this X, we don't know what that is. So get parent object, I assume it just means the ID of the object at this point. I guess we could look at here what it is doing at the line that we're trying for, which is 8CFB. That's because it's up. So we get the parent, we store an LO3, and then we test it. Yeah, so we're just getting the ID of the object. Makes sense to me. So I guess what we can do is make that method object. Now we already had something for child, I think, not chili. Do we not have something for child? No, we had. Well, we did JN. Yeah, so there is an object parent already, and what did that have? Just the object in the machine. Cool. But in the other order, I got a bit confused there, like I read it right. Cool, and that will be that. And I think, like, yeah, I don't know what I'm looking for there. That is because we need to cast it, right? Yeah, we need to cast it to use 16. It's kind of interesting the no typecasting thing that it does, because yeah, I guess like unsigned casting up never hurts, but it could, like, it kind of shows you that, like, yeah, maybe you should be doing something. So yeah, being explicit is kind of good, but it does kind of litter the code, which could tell you that your code's maybe not right. Could reorganize things differently, but the store is like kind of a weird field. Right, so now we're at the next instruction, I guess. It would be cool if like, oh, I just closed it. Cool. If it just knew what I wanted. Right, so we're at 8016. That's after. Right, so we actually did quite a few instructions there, I think. Well, that JN, or just like one. I don't know. Anyway, 8D16 get prop. That's 2 op 17. Oh yeah, 2 op 17. 17 decimal, and then 11 next to it is the hex. Kind of weird layout for this, but yeah, like, I'm wondering if I can kind of make this a bit better to read, and potentially on a new line. I actually think a new line could be better. I mean, it's small formatting changes, but the small things can help speed things up. Now, I just want to check that yeah, it does do the right thing, and then you kind of know what here, and then this 2. I think I just want to make this a bit grosser. And do something like this. So we've got a I'll just call it type S, and it's going to be a string, and we can do something like type S equals var op. How do we do this? We just call it var. So do something like that, but for these, so this is just going to be 0 OP. Just do the same there, and go back here and then do that and do that twice, and ext we just has ext. Type s equals ext. And here, I think having it as a %s will be, it just does it. But I want to do type s and do something like this, and then do no, it's down there, %d and then space, and do that. And then it'll kind of look more like this, and I can just search what I see. But then in this dictionary, yeah, I can still search that first one, except for these. So like 1-op is like 127 plus. So I think I also want to do like an offset, and this is going to be int, I guess. And offset can be equal to that search was like whack. Now, oh no, that plugin I need to get used to. So this is just 224 is the offset. 0-op 176. It's just up there, 128, offset equal 128. 2-op doesn't actually have any, I believe. Yeah, so 2-op has nothing. And ext should be down here, and ext also has nothing, but also just don't support ext. And so here we can do num. This can be plus offset, and then we can just have just num for the hex code. And so now I think if I run this, we don't know that. We can probably call this U8, and everything fits in it. We can probably find that one and get rid of it. And here we can probably just stay on dictionary, and we can search for 2-op 17. So we can search for 2-op 17. It should get right there, and the 11 is next to it, so we know that's the hex. And I think because I don't have now I go for that and then do that, I'll just do a colon there. And I think just because I did that, I'll just split this in case. Better debugging for unimplemented instructions. Something like that. Run. I think that is also a bit overkill. And if we just do opcodes, something like that, and I think for better get things, we probably should add these instructions. Get parent and print object. And I think this might be a good time to what would we add? And we got get. I wonder, add get parent, and what was the other one we did? Print object, print obj, and here if we have a look at the debug, and if we look at what is it, 8016 get prop, which probably can do, but also probably a bit trickier. What I think I might do is, it's a bit trickier. I was thinking this I could have as a line in this, but it's not actually that line. I'd have to search the file for that with the colon, which, yeah, I'm not too sure. So I'll leave it at that. Have a look at the status. Cool, that looks good. I'll push that up, and that's that. Cool. So I think at this point I'll leave it there for the video. Got a couple of things done, and yeah, it's getting to the kind of boring stage where you're just kind of implementing instruction over instruction. So I might just kind of go wild and implement a bunch of instructions off screen, but I also might not. Who knows? But thanks for watching, and for now I'll see you.